All right, so at the beginning of chapter 5, it's called analytic trigonometry. And the first lesson, we're going to be using those fundamental identities that we talked about back in chapter 4 on, I believe it was lesson 3 or 4. It's note sheet 25. So you can look at that note sheet to look at those identities. That's what we're going to be using for all these problems right here through this through this chapter right here. So starting off with this one, using the fundamental identities. And there's our practice problems that you can use at the end of the section. So first off, let's look at just simplifying a trigonometric expression. So we've got two problems right here. Let's do this first one, sine x cosine squared x minus sine x. So we want to simplify that. Sometimes what you've got to do is factor out something that each of the terms have in common. So we can see from this, this problem, both terms have a sine x. So if we take a sine x out of the first term, that's going to leave cosine squared x. And if we take a sine x away from the second term, that just leaves a 1. All right, so we've got cosine squared x minus 1. Now we know one of our trig identities is that sine squared x plus cosine squared x equals 1. Okay, so using that, all right, if sine squared plus cosine squared is 1, then obviously if we subtract cosine squared, right, we can get that sine squared is going to equal 1 minus cosine squared. Okay, so that's something that you will have come up a lot. 1 minus cosine squared is sine squared, and also 1 minus sine squared is cosine squared. So that looks very similar to this, except the terms are switched. Instead of cosine squared minus 1, it's 1 minus cosine squared. So what you can do is substitute this right here, all right, and for this right here, as long as you make it negative. Okay, if we took this right here and multiplied it by a negative, well, that's going to change the 1 to a minus 1 and the negative cosine squared to a positive cosine squared. So we can exchange those as long as we put a negative in front of it. All right, so let's say we got negative sine x. All right, and then we make this 1 minus cosine squared x. Okay, so we do that. We make a negative. And now we can substitute 1 minus cosine squared to be sine squared. So we've got negative sine x times sine squared x. Well, sine times sine squared is just sine cubed. So we've got negative sine cubed x. And that's as simplified as we can get that one. All right, so let's look at this next one. We got sine t times cotangent t times cosine of t. So whenever you start seeing cotangent, secants, cosecants, a lot of times the best thing to do is to change the sine, the cotangents, anything that's not sine or cosine, to be in terms of sine and cosine. So we can use the identity for cotangent, that cotangent is the cosine divided by the sine. That's one of our quotient identities. Tangent is sine over cosine. Cotangent is cosine over sine. So we have that times the cosine of t. All right. So then at that point, we can multiply cosine squared and cosine, multiply cosine and cosine to get cosine squared of t over sine of t. All right, now at this point we want to try to combine fractions, so we need to get a common denominator. So in order to make sine t have a denominator of sine, okay, if we give the bottom a sine of t, then we've got to give the top a sine t also. So now up top we have sine squared t over sine t plus cosine squared t over sine t. Now we can combine those fractions together and have sine squared plus cosine squared over, and of course you keep the denominator the same. All right, then we know that sine squared plus cosine squared is again 1, right, from this identity up here, one of our Pythagorean identities. So that's 1 over sine t, and we know that 1 over sine t is cosecant of t. All right, so all of that simplifies down to just be cosecant. All right, so I'm gonna go ahead and pause the video, let you guys try this one down here. Use those identities. I know you're wondering, you're thinking, well, how do I know when to use what? Well, when you've got fractions, a lot of times you need to combine fractions, so you need to find a common denominator. Again, if you see something that's not a sine or cosine, a lot of times the best thing to do is to convert it using, a quotient identity or a reciprocal identity. Sometimes you got to factor. So a lot of times you just have to try different things and look and see what's going to work, what's going to help you simplify things down. Sometimes it is just a trial and error type thing. So give this a try, and I'll answer questions if you need help. All right, so on this one, what you need to do is to combine them to be one fraction. So we've got tangent x over 1, and the other one has tangent x on the bottom. So what we need to do is multiply the bottom by tangent x to get a common denominator, and then we've got to multiply the top by tangent of x also. So up top, we're going to have tangent x squared. On the bottom, of course, will be tangent x minus secant squared. And on the bottom, tangent x. Now we can combine those. So we've got tangent squared x minus secant squared x over tangent x. Okay, now at this point, you've got to use one of your Pythagorean identities. And the clue to know that is when you start seeing tangent squared, secant squared together, because those are one of your Pythagorean identities. All right, one of your Pythagorean identities says that 1 plus tangent squared is secant squared. So when you start seeing those together, when you see sine squared, cosine squared together, and when you see cotangent squared and cosecant squared together, those are clues to use Pythagorean identity. So what we know is that secant squared is 1 plus tangent squared. So we're going to replace that secant squared. We're going to replace it with 1 plus tangent squared. All right, notice I put in parentheses. All right, and then at that point, we need to subtract both terms, so we end up with tangent squared x minus 1 minus tangent squared x over tangent x. Now up top, what's going to happen? Well, we've got tangent squared and minus tangent squared. Those are just going to cancel out. So we literally have negative 1 over tangent of x. So I left my x off. And we know that 1 over tangent is cotangent. So this is just negative cotangent x. All right, so right there you had to make them into a fraction, and once you made them a fraction, you had to recognize that Pythagorean identity would come in handy. Again, the clues when you see tangent squared and secant squared together. All right, so let's move on. Example 2, sometimes you got to factor. So they ask you to factor the trigonometric expression. So we got to remember our rules for factoring quadratics, difference of squares, right? Remember how we talked about difference of squares. If you have x squared minus 4, you could factor that into x plus 2 and x minus 2, because you're squaring x for the first term and you're squaring 2 for the second term. So you take those two things and add them, and you take those two things and subtract them. So that's difference of squares. And then also remember x box, right? So we're going to use those two things right here. So this first one, we just see two terms, secant squared theta and 1. So we're thinking maybe difference of squares. So what am I squaring? Well, I'm squaring secant and I'm squaring 1. So I'm just going to factor that into secant theta plus 1 and secant theta minus 1. And that's it. That's all I have to do on that one, is recognize it's a difference of two squares. I'm squaring secant and I'm squaring 1. Add those two things and subtract those two things. All right, on this next one right here, we see 3 terms. So when you see 3 terms, you're thinking x box or slide and divide. All right, so right here we've got 4 tangent squared theta plus tangent theta minus 3. So notice we're squaring tangent theta right here, and right here it's just tangent theta. So tangent theta is like our x, right? Normally we would have x squared and x right there. So now what we're going to imagine, instead of doing everything with x's, our x's are just becoming tangent thetas. So if this was 4x squared plus x minus 3, we would know how to factor that, right? So now those x's are just tangent thetas. So we're going to take the 4 and slide it over, multiply it by the 3. So that gives us 12. And now we can do our x box. So we've got 12, multiplies to be 12, and subtracts to be, remember there's a 1 in front of the tangent theta. Well, that's 4 and 3. So we're going to have a 4 and a 3. And to front now, instead of x, we're going to have tangent theta. Right, tangent theta. and we're going to put a plus on just one of the numbers, the big one. That means the other one's going to get a minus. Now the last thing you got to do is go back and divide by your 4. So we divide 4 by 4, divide 3 by 4. Well, 4 divided by 4 just gives us 1. So we got tangent theta plus 1. And over here, the 3 doesn't divide by 4, so we put the 4 back in front. The tangent theta, so it's 4 tangent theta minus 3. All right, and that's all for that. Okay, now we'll do one more. I'll do this one in red so it doesn't get confusing. So on this one, you notice that your trig functions aren't the same. You've got a cosecant squared and a cotangent. So what you're going to do on this one is use one of your trig identities right off the bat to make sure that your trig functions in here are the same trig function. So notice this is cotangent and this is cosecant squared. So do we have a trig function that or a trig identity that uses cosecant squared and cotangent? We have one of our Pythagorean identities. Cosecant squared is 1 plus cotangent squared. So we can change cosecant squared into 1 plus cotangent squared, and then everything will be in terms of cotangent. So we do 1 plus cotangent squared x, that's cosine, cotangent squared x minus cotangent x minus 3. All right, now the 1 and the minus 3 are going to combine. So I'm going to get cotangent squared x minus cotangent x minus 2. All right, now it's just x box. What multiplies to be 2 subtracts to be 1. 2 and 1. So I've got cotangent of x and cotangent of x. I'm going to put a 2 in one and a 1 in the other. And then I'm going to put a minus on the bigger number. So the minus goes on the 2, plus goes on the 1. And that one's factored as much as possible. Cotangent of x plus 1, cotangent of x minus 2. Alright, so I'm going to go ahead and pause the video, let you guys try this one down here. Let me know if you need help. Again, if they're not all, sometimes you might have to take GCF, sometimes you might have to do difference of squares, you may have to do X box, you may have to use a Pythagorean identity like I did on C part right here to change everything to be the same trig function. Alright, so first of all, always look for a GCF. Give these a try. So first one, you've got to factor out cotangent squared. So we take out a cotangent squared from each term. That leaves 1 for the first term, and it leaves negative cosecant squared for the second. So we notice that 1 minus cosecant squared, well, that is something we can use our Pythagorean identities with, because 1 minus cosecant, or I keep saying cosecant, sorry. 1 minus cosine squared is secant, or sine squared. So we can change 1 minus cosine squared to be sine squared. Now we have cotangent squared times sine squared. Well, cotangent is cosine squared over sine squared. So we change the cotangent squared into cosine squared over sine squared, and then times it by sine squared over 1. So on top we get sine squared, cosine squared, and on bottom we just have sine squared. Then our sine squareds cancel, so all we're left with is cosine squared of x. All right, be careful right there. You don't think to use sine squared plus cosine squared equals 1, because you're not adding sine squared and cosine squared, you're multiplying it. Okay, so you can't change that to 1 because they're not adding, they're multiplying. All right, on this next one, you see just 2 terms, so we got to use difference of squares. So what do I square to get sine to the 4th? I square sine squared, right? So I also do the same thing with cosine to the 4th. I square cosine squared. So the 2 things I'm squaring are sine squared and cosine squared. So I do sine squared plus cosine squared and sine squared minus cosine squared. And then once I get sine squared minus cosine squared, I use the Pythagorean identity that sine squared plus cosine squared equals 1. And so then I'm just left with sine squared minus cosine squared. I think I wrote the wrong one in here. So let me change that real quick. So sine squared minus cosine squared is the one that's left. Alright, because sine squared plus cosine squared equals 1. Not sine squared minus cosine squared. Alright, so that's as simple as that one gets. I know these are tricky. It's like, well, how do I know when I'm done? How do I know when I've simplified as much as I can? That's not something that is like an exact science all the time. So there's not really like a hard, fast rule I can tell you to say you're completely done simplifying. You just got to do as much as you can with the properties until you feel like you can't do anything else. Alright, so right here we're going to rewrite this trig function. I've got 1 over 1 plus sine x. And I can tell you on these, whenever you want to get rid of the fractions, what you need to do is multiply by the conjugate, right? Remember, the conjugate's where you use the same terms but just change the sign in between them. So I'm going to take 1 over 1 plus sine of x, and I'm going to multiply the top and bottom by 1 minus sine of x. All right, so whenever I multiply the bottom by that, I got to multiply the top by it also. So on the top now I have 1 minus sine of x. On the bottom, 1 times 1 is 1, and then the minus sine x times positive sine x is minus sine squared of x. Now I can use my Pythagorean identity that 1 minus sine squared is cosine squared. All right, so now I have it written over just one thing in the denominator. That was the whole point of doing that, is to make the denominator only have one term. So now when I do that, I can split this up into 1 over cosine squared x minus sine x over cosine squared. All right, and then I can change each of those fractions to be just one trig identity, so there's not they're not fractions anymore. So I can say, all right, well, 1 over cosine squared is the reciprocal identity of cosine is secant. So this is really secant squared of x. Now right here, this is a little tricky because the top fraction has just sine and the bottom is cosine squared, and there's no identity to use for sine and cosine squared. So what I need to do is split this fraction up into sine over cosine, and that's going to leave a fraction with 1 over cosine in the bottom, right? So I need to split that up into 2 fractions where there's a cosine on the bottom of each, and up top is 1 sine and one has just a 1. And the clue for that is that, you know, we need to get rid of those fractions, but the top fraction and the bottom fraction are different degrees. So I need to split those up and make 2 different fractions with cosine on the bottom of each. So now I can separate those. Sine over cosine is tangent using a quotient identity, and 1 over cosine is, of course, secant using a reciprocal identity. So now I got secant squared x minus tangent x times secant x. And I guess if you wanted to factor out a secant x and write it in factored form, you could, but they didn't ask us to do that. So that's a decent answer for that one. We don't have to factor it unless you just absolutely want to. All right, so you guys try this one right here. Again, use the same method, multiply by the conjugate. All right, so we multiply by 1 plus cosine y on top and bottom. So up top we've got sine squared y times 1 plus cosine y. And on bottom, when we multiply by 1 plus cosine y, we get 1 minus cosine squared of y. Then we use our Pythagorean identity that 1 minus cosine squared has to equal sine squared. So we change the denominator to be sine squared y. And now we've got sine squared y on top and sine squared y on bottom. Those will cancel out, and we're just left with 1 plus cosine y, which is as simple as we can get on that. All right, so last kind of problems we need to look at are using trig in substitution. So this says use the substitution x equals 2 tangent theta when theta is between 0 and pi over 2 to write the square root of 4 plus x squared as a trigonometric function of theta. Okay, so essentially all we're doing, that sounds like a lot of complicatedness, but we're taking this, and instead of x right here, we're going to plug that in for x. So we're just taking that and plugging it, substituting it in for x right there. So I'm going to write the square root of 4 plus, and then instead of x, I'm going to write 2 tangent of theta, and then we got a squared, right? So that's going to be 4 plus 4 tangent theta squared. All right, now I'm going to factor out a 4 from this, and that's going to leave 1 plus tangent squared. Now when you use a Pythagorean identity, 1 plus tangent squared, we know is going to equal secant squared, because that's one of our Pythagorean identities. So I've got square root of 4 times secant squared of theta. Now we take the square root. Well, the square root of 4 is 2, and the square root of secant squared is just secant. Right? So there's our answer. 2 secant theta is a simplified form when we substitute 2 tangent theta into that expression. All right, so go ahead and try this one down here. You're substituting 5 sine theta into this expression. So once we substitute this one in, we square it and we get 25 minus 25 sine squared theta. Then we factor out that 25, just like I did with the 4 on the last problem. So that gives us 25 times 1 minus sine squared. And we use Pythagorean identity that 1 minus sine squared has to equal cosine squared. So we've got the square root of 25 times the cosine squared of theta. And then you just take the square root of 25 and get 5. And the square root of cosine squared is just cosine. So our answer is 5 cosine theta. Again, I know these are a little tricky, but you just got to kind of use trial and error and use some of these strategies. Again, some of the main clues are whenever you're given a fraction and you're trying to simplify, a lot of times you need to combine fractions to give you one fraction. A lot of other times whenever you're simplifying, when you see, cotangent, secants, cosecants, you need to change those into sines and cosines to get things to cancel out. So you just got to use some of these different methods here and there. Look for, your Pythagorean identities when you see sine squared and cosine squared, or if you see tangent squared and secant squared together, or if you see cosecant squared and cotangent squared, then those are clues to use some of the Pythagorean identities. So just use those clues to help you out. And of course, let me know if you need any help. Go ahead and try these practice problems here, and I'll let me know. Let me know. I'll come around and help you when you need it.